Okay. Good morning, everyone, to our weekly SpaceGeekSpeak today meetings. And today we have a treat for sure. George Nield will be presenting us his fascinating first-person account of the mission and the training leading up to the mission on flying to space on New Shepard. George Nield is the president of Commercial Space Technologies Company, which he founded to encourage, facilitate, and promote commercial space activities. He also serves as a chairman of Global Space Alliance. He has more than 50 years of experience with the Air Force, National Aeronautics and Space Administration, NASA, the FAA, and in private industry. In March 2022, he flew to space as a private astronaut on board of Blue Origin's New Shepard rocket. He served as a FAA Associate Administrator for Commercial Space Transportation from 2008 through 2018. And prior to joining FAA, Dr. Nield served as Senior Scientist for the Advanced Programs Group at the Orbital Sciences Corporation. His previous assignments included working as an astronautical engineer at the Space and Missile Systems Organization, a flight test engineer at the Air Force Flight Test Center, and an assistant professor and research director at the U.S. Air Force Academy. He was the manager of the Flight Integration Office for the Space Shuttle program at the Johnson Space Center, and later worked on both the Shuttle Mir program and the International Space Station programs. A graduate of the United States Air Force Academy, he holds a master's and PhD in aeronautics and astronautics from Stanford University and an MBA from George Washington University. He is also a flight test engineering graduate of the Air Force Academy Test Pilot School. Dr. Nield is a registered professional engineer and a fellow of the American Institute of Aeronautics and Astronautics, AAA. Welcome, Dr. Nield, and it is a pleasure and an honor to host you here and listen to the first-person account of the flight to space and flight on a new rocket.
Well, thank you very much, Svetlana, and greetings, everyone. It's great to have a chance to talk with you. I see a number of familiar names on the call today, which is great. Spent 16 years down in Houston when I was working at the Johnson Space Center, and even had the privilege of chairing the AAA Houston section a couple of times in the 1990s. So it's great to see you all. I know many of you have had a chance to listen to NASA astronauts talk about flying to space. I have too, and I always enjoy it. My experience was very different. And so I'd like to spend just a few minutes today talking to you about what I went through and a little bit of the training leading up to that. So let's get started. These are the folks that I flew to space with. Marty Allen is a turnaround specialist from California. Sharon Hagel runs a nonprofit called Space Kids Global that tries to get young people, especially girls, interested in space and STEM subjects. Her husband, Mark, who also flew on the flight, is a real estate developer. Gary Lai is an aerospace engineer who works for Blue Origin, and he was basically the chief architect of the New Shepard rocket that we flew to space. So that was a real treat to have him on our flight. Jim Kishin is a professor at the University of North Carolina. He teaches entrepreneurship, and he's also a very well-known world traveler. He has been to every country recognized by the United Nations, all 193 of them. A couple of other interesting people that were important to our experience included Sarah Knights on the left there. She was the crew member 7. So she didn't fly on the flight, but she was the person from Blue Origin who was primarily responsible for our training. She was the last person we saw before launch and the first person we saw after we touched down at the end of the mission. And then Kevin Sprague on the right there was the Capcom, or capsule communicator. He was the person who sat in the Blue Origin mission control room and talked to us on the radio during our flight. Most of us on the flight flew into El Paso, Texas, 5 days before our scheduled launch date. And when we got up the next morning, we saw a bunch of these Blue Origin Rivian electric trucks out in front. They were there to pick us up and drive us out to the launch site. They also used these vehicles to shuttle us around for our training activities prior to the mission. Now, it was about a 2-hour drive out to Van Horn, Texas from El Paso, and a lot of the scenery looked something like this. There's just nothing out there. Very dry desert, beautiful, majestic, not a lot of people, and that's a good thing if you're trying to launch some rockets. We got to Van Horn. That's a sleepy little town, but they have some very talented artists, I guess, living there. One of the side streets off the main road had this mural showing Jeff Bezos, the founder not only of Amazon, but also Blue Origin, and his brother Mark. The two of them had flown on the first Blue Origin human space flight for New Shepard just a few months before we got to fly. So we stopped to take a look at that and got back in the trucks. And another 20 minutes or so, we got out to the actual launch site itself, which is a huge plot of land out there in West Texas. There's a number of different kinds of facilities they have as part of the overall launch site. The astronaut village is where we spent a lot of our time. And so it includes things like this building, the Kármán line, which was a great end of the day gathering place to catch up on what we'd been through and talk about what was coming. They had a small fitness center there as well. Just across the quad there, we found the Rock House. That's where we had most of our meals. Blue Origin did an excellent job of feeding us during our training. They had brought in some expert caterers from Los Angeles and delicious food during our stay. Each of us had a +1, often our spouse, that stayed with us, and we stayed in these Airstream trailers that were located there in the astronaut village. They were named after the original Mercury astronauts or the Mercury 13. So my wife Kelly and I stayed in this one, Gordo, named after Gordon Cooper. Very well equipped, very nice, fit in well with the relaxed Western Ranch theme of the area while still providing for all of our needs. After we dropped off our suitcases, my wife and I walked across the way there and checked in at the Kármán line. And although we had had a few Zoom calls in the months leading up to the launch, this was the first time we really had to get together and meet face to face with the other members of our crew. So here we are sitting in the chairs, and we also have Sarah and Kevin there with us. After we had a chance to visit a little bit and have some lunch, one of the first things we did was to do an inventory and then turn over the contents of our little blue bags. Each of us was allowed to carry 3 pounds of special mementos or souvenirs or things to remember our flight with us, actually with us during the flight. And so I decided to bring a couple of banners from some of the schools I'd been to at Stanford and the Air Force Academy, had some patches from my days working in the Air Force and at NASA, brought along some astronaut Legos for each of our 5 grandkids. And I don't know how many of you are familiar with the Curious George children's books. It's about a very curious monkey called George, who had a friend with the yellow hat. And he used to be very curious and get into lots of trouble, but have a great time. One of those books, which was written back in 1957, before any people or monkeys had ever been to space, was about Curious George flying to space for the first time. I used to love reading this book to my kids when they were young, and then more recently to our grandkids. And so I decided to take a copy of that with me on the flight. And Curious George ended up being sort of an informal mascot for our family during this adventure. Another nice facility there at the Astronaut Village was this fire pit here. You could sit around and relax during your limited free time. And it also provided a great perspective to enjoy some of the beautiful sunrises and sunsets out there in West Texas. Just gorgeous, clear sky, you can see forever. Next morning, woke up and were driven over to the Astronaut Training Center, which, unlike the Astronaut Village, was more of a typical aerospace facility. Had a classroom there with tables and chairs and pictures on the wall and diagrams. And then you see prominently featured there a mock-up of the spacecraft that we spent a lot of time practicing in and getting trained. Each of the companies that is taking people to space now has a little bit different philosophy and a little bit different kind of vehicle that they use. Blue Origin has decided to have a completely autonomous rocket and spacecraft. So there's no pilot on board. There's no pilot on the ground flying with a stick. Instead, the computer is controlling things. They have a fully staffed, very capable mission control room overseeing what's going on, but it's the computer that's really flying things. And that allows them to very much shorten and streamline and simplify the training that is required prior to the flight. Of course, NASA astronauts will typically train for many years before they get a chance to fly, but that's because they have a very active role in controlling the shuttle or other spacecraft. That's not the case here. We spent a lot of time practicing getting in and out of the spacecraft, and then strapping in and unstrapping, both under 1G conditions, and then what would be different when we were in microgravity or weightlessness. Here's the group of us inside the mock-up there. You noticed a few things. First, that cylinder in the center that we're all gathered around, that is a representation of the escape rocket motor that would be used in the event of a problem with the booster, either on the pad or during powered flight. If something bad were to happen with the booster, then that escape motor would light off and would separate the capsule from the booster, and then we'd come down under parachute, just like we do at the end of a nominal mission. The other things, you see some nice blue rings around that and elsewhere in the cabin. That was great things to grab onto when you're floating in weightlessness. You also see some cameras here at the top, and over on the left-hand side of the screen, there are actually 12 different cameras that they have inside the vehicle for video and stills, completely documenting the whole mission and giving us a lot of mementos after the flight to remember the experience that we had. We then got our flight suits, and we're encouraged to wear that during the rest of our training so that we'd feel comfortable with them. We had our crew portrait, and then spent a lot of time in the classroom as Sarah talked to us about the new Shepard booster and spacecraft itself, things we need to know about that, the overall trajectory that we would be flying, the timeline, and then the emergency procedures. What would we need to do under various conditions that might occur during the flight? So here I am inside the mock-up. A few things there. One of the very innovative things that Blue Origin has done is they made a recording prior to the human flights of New Shepard, and then they would play that back when we were in the simulator so that we could hear all of the sounds, all of the noises during an actual flight. And they cranked up the volume really loud too. So you see, I have hearing protection in the simulator even, because that's what it was going to be like during the flight. And I think that really was helpul to us to be able to hear the different sounds. There are a lot of very strange noises between the separations and the off-gassing and the thruster firings. And if you would hear that the first time on the flight, everybody would be looking at, what was that? Is everything okay? And so forth. But we were used to what it was going to be like. And so we were well prepared for the actual mission. Got a 5-point seatbelt and safety harness there to hold us into these very comfortable reclined seats that we had with armrests there. And you can see a very large window next to every seat. There are 6 of us flying, and each of us had a window seat with great view. In front of us there is the crew display. It had lots of helpful information there, including the mission elapsed time, altitude, our speed, Mach number, the acceleration or G's that we were pulling, and then any specific milestones in the mission that were coming up that we should be aware of. That little black box right above my head is where the emergency oxygen was stowed. And that's similar to what you would have on an airliner, but these masks were a little more sophisticated. They had a much better fit to the face than just the cup that you typically have on an airliner. Another thing we did was spend some time coloring. Blue Origin has a real neat concept, something called the Club for the Future. And if you or anyone you know has some youngsters, they're encouraged to draw a picture or write a little paragraph on what they think space is going to be like in the future. And if you send that to Blue Origin, they bundle them up, and they ride along on a future flight to space of New Shepard, and then they'll stamp it flown in space and ship it back to you. So they have a nice souvenir to get kids interested in space. So we were invited to draw our own picture for their historical collection there. We also had to come up with a name for our crew, a name for our mission. So we were on the 4th human flight, but it was actually the 20th launch of the New Shepard rocket. And we figured we were going to make some noise at liftoff, so we decided to call ourselves the Roaring Twenties. We also got a chance to visit the Mission Control Center, and the tour guide for us there was Nicholas Patrick. He used to be a NASA astronaut and has flown on the space shuttle, so that really gave us a lot of comfort to know that he was the flight director for our mission. And here he was showing us around the facilities. We also had a visit to the barn where the rocket and the spacecraft were being prepared for our launch. Of course, here it's in the horizontal position. We got a chance to check that out prior to our flight. Then we went out to the launch pad itself. Now, the rocket isn't there yet, but this is us getting used to what to expect and where it was located and how we would access the platform there where we would enter the spacecraft. When it came to the actual launch day, there was a very early wake up. I think it got up about 4 o'clock in the morning. Since this was such a short mission, we didn't have to worry about the crew being quarantined. And so it was really great to be able to get together with our family and friends right before we flew, give them a big hug and tell them we loved them. And then it was time to hop in the Rivians and drive over to the astronaut training center one last time. We put on our flight suits, and then Sarah one more time went through, here's the timeline, here's what's going to happen, here's the emergency procedures, one last run through in the mock-up, here's how it's going to go. Bob Smith, who's Blue Origin's CEO, stopped by to assure us of his personal involvement in overseeing the safety of their operations and to wish us Godspeed on our flight. So I thought that was a very nice gesture on his part. 45 minutes before the scheduled launch time, we were driven out to the launch pad. And that's when it really became real. standing there looking up at this big rocket fully fueled. It had been moved out to the launch pad itself about 8 hours prior to the scheduled launch time, and it was fueled about 3 hours prior. And wow, it gives you chills just looking up at that, knowing you would be flying on it soon. The rocket itself uses liquid hydrogen and liquid oxygen as the propellants, and have to be pretty careful with hydrogen. NASA had some challenges with hydrogen on their Artemis mission. You don't want to have too much hydrogen accumulating around the base of the rocket or have any sparks or anything that might set off an explosion. So you see that tall pipe there in the center, that is excess hydrogen being burnt off. Since the rocket is fully fueled, they don't want it to be gathering at the base of the rocket there. And here's a view from the other side. We are now in the process of climbing up 7 flights of stairs to get up to the access walkway to the spacecraft. You'll notice a little small building right at the top of the stairs, shelter. We'll talk about that in just a second. So 7 flights of stairs. Normally, I think I'd be huffing and puffing at the top, but I guess the adrenaline must have kicked in. We didn't even have to stop to catch our breath. It was a beautiful day. And here we are inside that little safe room or shelter at the top. This is where we were told that we would go if there had been an emergency right before launch, after the ground crews had all been evacuated. So we would run over, get inside this room, close the door. They had emergency oxygen. There was a radio. There were first aid kits and so forth. And we were assured that even if the rocket had exploded on the pad for some reason, if we were in this shelter, we would be kept safe. So that was encouraging. At that point, we lined up single file, started to walk over to the rocket. Right underneath this archway, it says, "Light this candle." You may recognize that as the words Alan Shepard said to his flight control team prior to becoming the first American in space when he was anxious to get going. Blue Origin also has a very nice tradition that they've started. All the folks that are scheduled to fly to space there are encouraged to ring this silver bell on the right side there prior to departing, just to sort of announce you're getting ready to go and to head off to space. We walk down the walkway. Here you can see the platform. And then we lined up there as Sarah checked in with mission control to make sure everything was still on schedule. And we each, one by one, went over to the spacecraft, turned around for one last photo shoot, and then climbed in. You notice some writing right above the hatch there, RSS first step. That stands for Reusable Spaceship First Step. And that is a reference to Jeff Bezos's long-range strategic vision and mission for Blue Origin, which is millions of people living and working in space to benefit Earth. Great strategic vision. It's going to take a long time to do that. But the first step to get to that eventual goal is to figure out how to safely and reliably and repeatedly send people to space. And that's what the new Shepard program is all about. So here's Gary Lai sitting in seat number 1. You can see how large the windows are. Just fantastic. I was in seat number 2 right behind him. Sarah came inside with us to check that our straps were all nice and tight and make sure everybody was good to go. Got a final thumbs up from everybody. And then she left the spacecraft, closed the hatch, walked down 7 flights of stairs, hopped in a Rivian and drove several miles away so that if something bad did happen to the rocket, at least she would be safe. As soon as she had gotten safely away, then the escape system was armed. And so from that point forward, if anything off nominal was taking place, if there was danger with the engines and the fuel system or anything else, then the capsule could use that escape system rocket inside to blast us away from the booster. And again, we'd come down under a parachute. But at this point, we were all alone on top of a fully fueled rocket. Time to catch your breath and think about what was about to happen. T-minus 10 minutes. They had the final go, no-go poll of mission control. And then 5, 4, 3, 2, 1, ignition. And we see this really bright orange flame out the window. And it was even reflected in the white ceiling on the spacecraft. And the rocket engine comes up to speed. And at 6 seconds, it was time to go. Now, I've heard lots of NASA astronauts talk about flying in the shuttle, and they said their liftoff was like a kick in the pants. Well, they had solid rocket boosters that provide quite a jolt, I guess, at liftoff. We didn't have that experience. We had a nice liquid booster. It was a very smooth and rapid acceleration, about 3.5 Gs during ascent. And then after about a minute, went through maximum dynamic pressure, or max Q. A little over 2 minutes later, time for MECO, main engine cutoff. And then a few seconds after that, bang, the capsule separated from the booster. And then we were given the go-ahead to unstrap and float around. So we all gathered around the center there for a picture. And you just can't help but smile. It's just such a joyful, exhilarating experience. You remember Jim Kitchen, our world traveler, as one of his things in his souvenirs, he brought along his passports. So I pretended to stamp the passport to mark a new boundary that he had crossed during the flight. Time for a few somersaults and just appreciate the three-dimensional space that had access to in the microgravity environment. But most of the rest of the time, I was just glued to the window. Everybody's got a different experience, but for me, by far, the highlight of the flight was the view. To look out those huge windows and see the curvature of the Earth and that thin blue line that's the atmosphere that you're above. And then above that, it's not blue sky. It is the blackest black that you can imagine. And that whole picture, it's just the most beautiful thing that I've ever seen in my life. It just gives me goosebumps even to talk about it after the fact. Just fantastic, awesome experience. Pictures and videos do not do it justice. It's an incredible experience. So we had about 3 minutes of weightlessness to enjoy, and then it was time to climb back into our seats and get all buckled in as the capsule was starting to descend down and encountering the atmosphere. And once again, we were being pushed back into our seats. We actually got up to about 5.5 Gs for a few seconds during reentry, which was more than I remembered it to feel like. About that time, the booster, which fell a lot faster than the spacecraft, had descended towards the Earth, and they had relit the rocket engine for a nice soft landing on the landing pad, which is about 2 miles away from our launch pad. And here's what it looked like then after it had safely landed. Meanwhile, the spacecraft, the 3 drogue chutes, had popped out to stabilize things and start to slow us down a little bit, followed by 3 big, beautiful parachutes for a nice, smooth descent down to the desert floor. Now, any of you who might have seen the Blue Origin flights on TV or video might have been concerned that it seemed like a pretty hard landing because there's a lot of dust that was kicked up. But that's just West Texas desert dust, really. And the fact that at the very last second, there are some little thrusters that fire to soften the touchdown even more, similar to what the Soyuz does. And so the final little impact was just like sitting down in a chair hard, but not a hard touchdown by any stretch of the imagination. So here we are. That's me waving out the window there. They had a drone right away there to circle around and take pictures to see the parachute lines. It took about 10 minutes for Sarah and the rest of the ground support team to drive over to our touchdowns point. And she opened the hatch for us. And then it was time for us to come on down and wave to the folks there. Each of us was allowed to have our +1 right at the landing site there to greet us, which was very special. So I made a beeline over to see my wife, Kelly. And I think I probably had a little better appreciation than many folks do of the risks associated with flying in space. And so it was a thrilling experience, but having it go well and having the chance to give my wife a big hug, that was really special. Definitely a good feeling. And it was time for a quick little video interview with Sarah after the fact. How was it? It was awesome. What was your favorite part? It was the view. We then gathered for some last minute pictures there with Bob Smith, the CEO, and Sarah, our crew member 7, and the capsule behind us. And they had a very nice ceremony right out there where Audrey Powers, who's one of Blue Origin's vice presidents, and who also had flown on New Shepard just a few months before we did. She was on the flight with William Shatner, Captain Kirk, and so she knew what it was all about. And they had a very nice presentation to get our Blue Origin astronaut wings. So little A with the feather as the crossbar, and very nice little ceremony for us there. Then we headed back to the Astronaut Training Center and got to meet the rest of our friends and family and tell them all about it. And then after we had something to eat, we headed back out and got to see the booster that we had flown that had now been safed, and we could get up close and walk around and have some more pictures taken. Here I am with my family, our daughters and their husbands, and all 5 of our grandkids. Notice the Curious George t-shirts that everybody had, so that was special for us. And it didn't take long before Blue Origin had mounted the booster horizontally on a flatbed truck there and driving it back to the barn to start getting it ready for the next mission. And we got to spend the rest of the day enjoying all of our family and friends and telling stories and reminiscing and trying to grapple with what we had been through and enjoy those beautiful West Texas nights. And then the next morning, we had a very informal debrief with Blue Origin employees. So they had a chance to ask us questions, and we got to thank them for keeping us safe and get our picture taken with all of them. And then it was time to hop back in the car and head to the airport and head home after what had been one of the most incredible weeks of my life. So it was just a thrilling experience. I hope any of you who are interested someday will get a chance. I had worked my whole career in aerospace, in the Air Force and in NASA, for the FAA and for industry, and had retired and was 71-year-old before I got my chance to fly to space. But boy, it was worth the wait. So happy to answer any questions that folks have. And thanks a lot for having me here today to talk to you.
Thank you, George. It was fascinating. Just by listening how you describe your experience. I can only imagine how exciting it was during those moments in space, in microgravity, in zero gravity, and watching the stars, or the black, as you described, the black, the black is black, that was giving you goosebumps. That is fascinating. I do have a few questions myself, and then I also was monitoring. There are a few questions that were posted in the chat. So I wanted to ask that you briefly mentioned or touched on the safety, how during a debrief, and then there was a provided space if there's any malfunction or anomalies, that would be a safe place for the crew to be. Were there any in general, because you are an expert in the area of commercial space transportation, and in FAA worked many years. What are some of the key safety considerations or regulatory changes faced by companies like Blue Origin as they work toward human spaceflight capabilities?
So, excellent question. First of all, I think it's important to recognize that, as Congress pointed out in the 2004 Commercial Space Launch Act, spaceflight is inherently risky. In all of the flights that the United States has flown to space with people on board, there have been about 400 of those. And out of that 400, we've had 4 fatal accidents. One X-15, Space Shuttle Challenger, Space Shuttle Columbia. And then there was one early test flight of Spaceship Two when it was being conducted by Scaled Composites. And so that's 4 out of 400. That's about a 1% fatal accident rate, which is 10,000 times riskier than the risk with flying on a commercial airliner today. So people need to be aware of that. And as a result, Congress has set up this regulatory structure for commercial space transportation that is very different from how we handle aviation. In aviation, the FAA certifies the aircraft, and you have every expectation that you're going to safely arrive at your destination. And fortunately, we see that flying today is the safest way to travel. There are very few commercial airline accidents these days, which is wonderful. It took us a while to get there, but we have learned what's important over the years. It was recognized right from the start that space was not going to be that way, at least at the beginning. And so Congress set up this regime known as informed consent. So prior to people flying in space on commercial rockets, they have to be thoroughly briefed on all the risks, all the hazards, all the things that could go wrong. They could be seriously injured. They could die. Are they still willing to go? If so, sign this piece of paper. And so they need to understand that process in the same way that you're briefed before a major medical operation, that here's the risk, here's what you have to recognize could happen. We don't think it will, but it could. And people need to go in with their eyes wide open. So with all that as sort of a long introduction, the companies today are certainly trying to be as safe as they can. They have a lot of great history from NASA and from other companies who are slowly but surely learning how to do this more safely and more reliably, but there still is risk, and people need to recognize that before they buy a ticket to fly these days.
Thank you, George. So before I proceed with my questions, I want to ask some of the questions that have been posted here in the chat. And Rock was asking, were the seats and suits custom fit for every passenger, like they do for the orbital space flights? Or does Blue Origin have a selection of pre-made hardware for different body types and sizes?
Okay, great question. So first, a couple of things. So this is a relatively short suborbital flight. The whole flight was 10 minutes. And again, it would have been possible for loss of pressure or some kind of other problem that would be very serious if you were above 100 kilometers and when that took place. But Blue Origin has made the decision that rather than having everybody custom fitted for a pressure suit, a space suit, if you will, they would just make extra sure that there are backups in terms of the chance of loss of cabin pressure with double hulls and window panes and so forth, and then having emergency oxygen and a way to replenish the oxygen enough for 10 minutes to get you down to a lower altitude. So didn't have pressure suits. They did have us have measurements of every part of our body in terms of how our flight suits would be fitted out. And so they were waiting for us when we arrived and then could be tailored at the last minute if additional changes needed to be made in terms of how you reach your arms and so forth. So that was how that was handled. The seats themselves, again, at the arrival there, they knew how tall we were, how long our arms were, and how long our legs were, and so forth, and were able to make adjustments to each of the seats so that they were appropriate for our body type and size, and they were very comfortable, and again, right by those huge windows, so that worked out well.
Thank you. During launch, did they show the rocket on the screen so you could watch the launch from inside the spaceship? Did you have a visibility of the launch itself, the ignition and all the stages?
So we did not. We had the huge windows, and so as I mentioned, right from ignition, we could see the orange flame out the window and down and reflected on the ceiling, and we could see the clouds whizzing by, and we could hear the different stages, the rocket and the venting and the air whooshing by and all those kinds of things, but we couldn't see the perspective. I suppose they would be able to do that, but again, they were focusing all of the communications bandwidth on data from the rocket, and so they didn't want extra real-time video to interfere with that in terms of having the displays. Plus, you wouldn't want to just be watching TV. You want to be sucking it all in and looking outside. And so that's what we did. The screen in front of us was very helpful in terms of time and altitude and speed, Mach number, acceleration, and so forth. And then there was actually an alert panel right above that would flash if there was a need for emergency egress or abort system firing or something like that. So good displays, but we couldn't see from the outside during the flight. We had to wait for after the fact to hear that or to see what it was like.
And George, you mentioned that you are working on inspiring younger generation to proceed into learning science, technologies, and work toward the improvements in space flight and the other areas. So we have a question from one of those students, and Esther is asking, what was the most important tip you learned in the classroom before you went into your flight?
So the things to learn before the flight were the emergency procedures, what to do if something went wrong. And so that was very, very important. But something I have learned and appreciated now, having flown in space, is we in aerospace need to do a much better job of telling our story. We emphasize math and science and STEM subjects. Yes, we're going to need lots of engineers, scientists, doctors in the future. But if some of these grand visions of millions of people living and working in space to the benefit of the Earth, if that's ever going to happen, we're going to need lots of different kinds of people. And so if you have a passion for space, whether you are a lawyer, an artist, a technician, a welder, a mechanic, whatever your skill set, whatever your job, if you're passionate about space, there is going to be a place for you. So hang on to that and be patient because it's coming.
Thank you. I agree so much with you that there's a space for everyone and everything in space. And we need all kinds of experiences, expertise, and the thought thinkers also in order to explore space. And thank you, Esther, for putting that question. Any other questions? Okay, I have one that relates to a commercialization in space exploration. What challenges or obstacles do you anticipate for companies like Blue Origin as they move forward with their goals of increasing access to space?
So safety is going to be important. I think another thing that will be very important is learning to share safety data with other companies more. That's what we do in aviation now. That's enabled us to learn from different companies about problems, issues, surprises, human error, and get smart as an industry. And I think the tendency right now is for each company to just hold everything. Well, this is our proprietary information. This is our trade secret on how we're going to have the best system and so forth. But when it comes to safety, I think we all benefit if we can all be successful. So sharing is going to be important. And then figuring out how to have some near-term revenues coming in will also be very important. Having rockets and spacecraft is expensive. And so it's not something necessarily that you can do in your backyard or your garage. And so where is your initial capital going to come from? And whether that's raising funds on Wall Street or with angel investors or with lots of wealthy customers, whatever it is, you're going to have some dollars coming in at the beginning while you get your system up and running and proven, so that then you can have more long-term customers. And so that'll be a challenge, but I think it's very doable. We're seeing now with multiple companies flying people to space. The International Space Station is coming to the end of its expected life by 2030, maybe. And there's a number of companies who are preparing to build commercial space stations to take its place. Axiom has already been awarded use of one of the ports on the ISS so that it can have its module attached to the ISS and get some experience there. And then after ISS is retired, it would separate and become a free-flying spacecraft. 3 other companies have each been given more than $100 million each to start designing, building, testing their own commercial space stations. So there's a team with Sierra Space and Blue Origin. There is a team with NanoRacks, and there's Northrop Grumman. And then just recently, we saw an announcement that a company called VAST, V-A-S-T, has signed a contract with SpaceX to fly what they say is going to be the first commercial space station in 2025. And they already have the flight booked and a follow-on flight to take people up to that. So again, some of these may not happen, at least in the time frame that they're talking about, but I'm seeing more and more interest and more companies that are recognizing, hey, there's a place for us. We used to joke recently that every company is a space company. Some just don't know it yet. So we're going to have to figure out, what can you gain from space? What can you do in space? What can you make in space? Lots of questions, lots of room for creative, innovative ideas.
Very good. Thank you. So a couple more questions. One is, does Blue Origin have plans to make an orbital rocket spaceship in the future so you can achieve orbit?
Yes, great question. So I flew on the new Shepard, and that is designed for suborbital flights. So you just get lots of good experience with that. But right now, they are building a rocket they call New Glenn, and they're building it down right outside the Kennedy Space Center. And they're also refurbishing a no longer needed launch pad to be a very nice facility. I've been out there for a tour, and it's first class, really great. It's a very large rocket, orbital class. And again, it is fully reusable is the plan. And so again, the goal is to have less expensive ways to safely and reliably take people and cargo to space. And they're hoping to have their first flight, I think, next year. So it won't be long.
Okay. And how was your crew paired together before the flight?
So I don't know all the answers to that. I can tell you my personal experience. So again, I had wanted to go to space since I was a child, applied to be a NASA astronaut, made the finals a couple times, was invited down for a physical interview, didn't make the last cut. Here, we had Jeff Bezos make an announcement in the spring of 2021 that he was planning to fly on the first human flight of New Shepard. And on one of those seats, they were going to have the winner of an auction fly. And they also invited Wally Funk, a famous woman aviator, and Jeff's brother, Mark, on the flight. So they had an auction. I didn't know how many people were going to put in a bid or whatever. So I filled out the paperwork and put in my bid, and then was watching the auction, and then the prices just started going sky high. And I was like, okay, well, I tried. But a few months later, company got back with me, said, okay, well, you didn't win the seat for the auction, but would you be interested in flying on a later flight? Yes. So that's how that works. So I bought a ticket, and it was expensive, but it was worth every penny. And we found out just a few months before launch who the other people were that were on that particular mission. And my understanding is they have a lot more in line now that are willing to buy tickets.
Okay. Okay, that was interesting. And I can imagine the adrenaline of watching the bidding or going on and getting to the cap and then going over the cap. That is I can only imagine the feeling. Tom Bryan asked how did your flight compare to what you expected? Did anything really surprise you?
Another great question. So again, I had been enamored with space, been reading about space, worked in the space field my whole career. I'd had the opportunity to fly in the back seat of high performance jets when I was at the Air Force Test Pilot School at Edwards. I'd done the Vomit Comet flights when I was at NASA there, feeling 20 seconds at a time of weightlessness. I'd been in an altitude chamber, been in a centrifuge, and had acceleration forces and so forth, and watched lots of movies, science fiction and the rest, and the real-time stuff. So I had a pretty good sense of sort of what it was going to be like, but it completely exceeded all my hopes and dreams and expectations in every way. And as I mentioned, the high point to me was just the view, just spectacular. You just can't express what it's like to see the beauty of the Earth. It just, pictures and videos do not compare at all. It just was so surprising how beautiful it looked.
It is fascinating, and I'm sure it was absolutely amazing. Jeff is asking, do you think we will ever reach a point where commercial spaceflight will be available to the general public interested in it, rather than those that have a bit more disposable income, know the right people, or already work in the spaceflight industry?
Yes, I do think that'll happen. It'll probably take longer than we would like, but even now we're seeing organizations that are basically inviting people to apply for a scholarship, sort of, if you will, or to say why they think they should be chosen, and then they get sponsored to pay for a ticket, or there's certainly a great desire to have all different kinds of people have this experience, because it's just such an amazing experience. It's a life-changing experience. At the same time, we want these companies to be financially successful so they can keep improving the rockets to make them safer, more reliable, and lower costs. And so the fact that they're willing to pay relatively high prices right now is a good thing in the long run, because that's going to allow lower prices in the future. And so how long will it take? Don't know. But as we mentioned earlier, it's going to take all kinds of people to eventually do these wonderful things in space. And so when we get these commercial space stations, we're going to need chefs, we're going to need welders, we're going to need electricians and all that. And so it's not a question of, well, how much income do you have or how much savings do you have? It's going to be, okay, you have the right skills for the job. Are you interested in going? All right, let's pick the workers for this mission and go from there. The other possibility for a game changer is SpaceX with their Starship. Again, Elon Musk is designed this to colonize Mars, right? Or to take NASA astronauts down to the surface of the moon. Fantastic. That's great. And it's reusable, and it's a lot cheaper than some of the previous alternatives we've seen. But that system is going to have the capability to fly 100 people to space on one flight. And now, how long is it going to take to have that demonstrated and have the bugs worked out? I don't know. I'm sure he's not afraid to try some things as he figures out the best design. And so we'll see how that goes. They took them several tries before they figured out how to land the first stage of the Falcon 9. Right now, they've done it hundreds of times. So once they get the Starship going and we can fly 100 or more people at a time to space, that could be the trigger that really opens things up. And I know other companies are trying to do this too, but we're seeing this right now with SpaceX trying to go with the Starship.
Thank you. Rock is asking that based on your experience, do you think professional and commercial orbital astronauts should take a suborbital flights as part of their astronaut training?
I personally think it would be excellent preparation. I know NASA has thought about it in times, and I think they have mixed feelings about it. On the one hand, they appreciate and benefit from having complete control of it. Here's our rocket, here's the training facilities, here's what we need them to know, and here's when we want it scheduled, and so forth and so on. But we just saw some Italian Air Force members and experimenters fly on Virgin Galactic on its most recent flight. And I think some of those folks hope to eventually fly to space as well. And they decided this is available now. It costs a lot less than flying to orbit. Let's give them that experience, do some experiments on board, and see how that works out for us. So the United States may decide to do something similar in the future.
Okay, Mike had posted that if you can address the failure of the rocket last year.
So they have studied that very carefully and actually put out the report. So that is, I don't have that at tip my fingers here, but that is available now on what they found. And this was a flight without people on board. It was just for experiments. And apparently, at one point in the flight, they had a material failure on one of the rocket engine nozzle that had higher heating than they had anticipated, and that affected the thrust and the attitude of the rocket. And as soon as that was detected, the computer kicked in and said, "Whoop, abort situation." So the capsule fired the escape rocket, and the capsule came, and all the experiments came down in a parachute safely. And so they were saved. The booster was not performing correctly, and so it was not recovered. But they have been studying that and apparently figured out what they need to change and improve in the future. And I recently saw an announcement that they expect to re-begin flights in the very near future. So hopefully they've got that figured out.
Okay, thank you. So I have two more questions, and I think this will be it for today. And one is, what distinguishes Blue Origin from other commercial space companies, and what potential impact do you see them having on the broader aerospace industry?
So it's very exciting now in commercial space that it is not just one company. It is not just one rocket. We're seeing lots of folks getting involved in trying to figure out what can they contribute, what can they benefit from, and how can they move the industry forward. And so if you look at the three companies that are taking people to space, SpaceX, Blue Origin, Virgin Galactic, they each have three very different kinds of systems, but they each have a niche market, if you will, and something that they believe is a good way forward. And other folks are watching from the sidelines to see if they can figure out, okay, that works, that doesn't. How are we going to design our system? And so I think having competition is a great thing. We can all encourage one another, and we can pick the ones that work best for us. So I'm excited about that particular aspect.
Okay, Dave snuck one question that before I ask the last one, I'll ask his. I think I wasn't thinking about it, but I believe that it will be interesting for a lot of people. Do you think that suborbital flights will lead to halfway around the world commercial transportation?
Without a doubt. I am passionate about that one. I think that is something that most people have not yet appreciated or thought about. So we talked about Starship. That same rocket that can go to Mars and go to the moon will be capable of taking hundreds of people from one side of the planet to the other in a half an hour or an hour. And, you know, what is the cost benefit for that? I don't know. Gosh, after spending 17 hours plus to go to Australia or Japan or whatever, wouldn't it be nice? And maybe it's not for everybody, and maybe it has to have certain kinds of G profiles or whatever that make it more acceptable to airline passengers. But as I've been looking into this, it turns out that there are 150 million people who fly on airplane flights longer than 10 hours every year. So if 10% of those folks might be willing to buy a ticket on a rocket instead, if it was dramatically decreasing the flight time, and it was about the same cost or maybe a little bit more, that would give us more revenues coming in than we're spending on all of our launching for satellites now. So that has a huge potential for game changing, for national security, for doing business, for tourism, for seeing family and friends in the rest of the world. Yes, 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 it's going to happen. I think it absolutely will happen in the next 10 years.
Okay, thank you. And to close this, what advice would you give to individuals or organizations interested in participating in the commercial space sector, based on your experiences working with companies like Blue Origin?
Don't be shy. Learn, listen, get engaged with AIAA and other groups that are talking about this, and get a chance to meet people and talk to people and see what it's like. And then if you're interested in space, as we said earlier, stick with it. There's going to be a place for you, whether you're in math, science, engineering, or some other field. So don't be afraid. Just come on, knock on some doors and ask how you can help. And I'll bet they'll find you a place.
Thank you, George. Really appreciate your coming here. And I'm looking forward to our future interactions, because I think you have a lot to share on the commercialization of space, on the diversity of space, and making space available for everyone. Thank you, everyone, for joining AIAA SpaceGeekSpeak, and I'm looking forward to seeing you in our next sessions. Have a great weekend.
Bye-bye.
Thanks.
Thanks so much, George.
You bet.